Hello, hi, this is Vamsi. Today's our topic is storage structures. Storage structures. Storage structure refers to a organization and management of data in a computer system. It encompasses how data is stored, accessed, and managed across various storage devices and mediums. Effective storage structures ensures that data can be retrieved quickly and efficiently while maintaining integrity and security. Difference between the primary and secondary storages. Primary storage is also known as main memory. Definition. Primary storage or main memory refers to the computer memory that the CPU can access directly. It primarily includes RAM, random access memory, and cache memory, and both of which is volatile. Characteristics. Volatility. Data is lost when the computer is powered down. Components includes RAM and cache memory. RAM is further divided into two like DRAM and SRAM, with DRAM becomes more common due to its cost effectiveness despite being slower and less power efficient than SRAM. Speed. It is much faster than secondary storage, providing quickly access to data and instruction needed by the CPU. Cost more expensive per unit of storage compared to a secondary storage. Capacity generally smaller in size compared to secondary storage option. The second one is secondary storage. Definition. Secondary storage refers to a storage devices that provide permanent data storage even when the computer is powered off. Characteristics. It is a non-volatile, meaning it retains data without power. It includes devices like hard drives, SSDs, CDs, DVDs, and USB flash drives. Speed. Slower than primary storage. Cost. Less expensive per unit of storage. Capacity. Larger in size. Types of storage devices and their characteristics. Hard disk drives HDDs. Its characteristics is mechanical devices with spinning disks and read write hands. They offer large storage capacities at a lower cost, but are slower compared to SSDs. Use cases suitable for mass storages of data, including operating systems, storage software applications, and large files. Solid state drives SSDs. Characteristics use flash memory to store data with no moving parts. They are faster and more reliable than HDDs but are more expensive. Use case preferred for operating systems, frequently accessed applications, and data required high speed access. Optical discs, CDs, DVDs, Blu-ray discs. Its characteristics is user larger technology to read and write data. They have lower storage capacities compared to HDDs and SSDs and relative slowly. User cases ideal of media distribution, backups, and virtual storage. USB flash drives. Its characteristic is USB flash drives are portable and user friendly, offering moderate storage capacities. They are known for the fast access times compared to optical discs like CDs and DVDs. Additionally, they are durable and can be across various devices with USB ports. User cases is these drives are commonly used for transferring data between devices and providing temporary storage solutions and creating backups of important files. Their portability makes them ideal for on the go data management. Network attached storage NAS. Its characteristic is NAS is a dedicated file storage system connected to the network, enabling multiple users and devices to access and share data simultaneously. It features centralized management, high storage capacities, and often includes data redundancy and backup capability for improved reliability. User cases: NAS is particularly suitable for environment that requires collaborative work such as offices and homes with multiple users. It serves as a centralized storage solutions making it easier to manage and access shared files, and is also used for backing up data from various networks and devices. The second topic is microprogramming. The microprogramming is a used technique used to implement the control logic of a computer central process unit CPU. It involves writing a set of low-level instructions that defines the operations of the CPU's control unit. These micro instructions are stored in a special storage called control store. Role in computer architecture. Microprogramming plays a crucial role in defining how a CPU interrupts and executes mission level instructions. By using micro instructions, complex CPU instructions can be broken down into similar, more manageable operations, allowing for more flexible and efficient control of the CPU. It, these about the diagram. We can see it. And the second next topic is how microprogramming controls execution of instructions. Control unit. The control unit of the CPU fetches and decodes instructions from the main memory. Micro instructions. Each mission level instruction is associated with a sequence of micro instructions. Execution. The control unit executes these micro instructions step by step to perform the desired operations, such as arithmetic calculations, data movement, or logical operations. Here are the advantages and disadvantages of microprogramming. Firstly, we go through about advantages of microprogramming. In advantages, we have three topics. One is flexibility, simplification, error correction. Flexibility is to easier to modify and extend the instruction set of the CPU. Simplification simplifies the design of the control unit by breaking down complex instructions. Error correction easier to debug and correct error in the control logic. And the disadvantages, speed. Microprogrammed control units can be slower compared to hardwired control units due to additional layer of instruction interruption. Complexity. Rating and maintaining microprograms can be complex and time consuming. Cost. Requires additional memory for storing micro instructions. Here are the this is a table about the disadvantages and advantages of microprogramming. In first of all, we go through about the disadvantages. Flexibility. Microprogramming allows for easy modification and updates to the instruction set of, enabling quick adoptions of new requirement or bug fixes. Simplified design. It simplifies the design of the control unit, making it easier to implement complex instructions and control signals. Extensibility. New instructions can be added without significant hardware changes, making it easier to extend processor capabilities. Standardization allows for a standardized control logic that can be reused across different processors design with minor adjustment. Ease of emulation. Microprogramming can facilitate the emulation of the other architecture, allowing the one machine to mechanic the behavior of another. The last one is debugging and maintenance. Error in microprogrammed control units can often be fixed by updating the microcode without needed hardware modifications. In disadvantages, the first one is performance overhead. Microprogram control units are generally slower than hardware control units due to the additional layer of interruption. Increased complexities. The design and debugging of the microprogrammings are complex, especially for very complex instruction sets. My memory usage. Microprogrammed control units requires additional memory to store the micro instructions, which can increase the cost and size of control unit. Latency. The use of micro instructions introduce additional latency of each instruction may require multiple micro instructions to execute. Power consumptions. The additional memory access and operations in microprogramming can lead to the higher power of consumption compared to hardware control units. Potential for errors. Writing and maintaining a microcode can be error prone, requiring through testing and validation to ensure reliability. This is the first part of our storage structures. Will be continued in the next part. Thank you.